Hi, dear audiences, welcome to our show. This channel provides knowledge of power systems for insiders, and our team is committed to offer professional explanations and answers. Today, let's continue to explain basic knowledge about power cables. First, let's look at cable accessories. Cable accessories mainly refer to cable terminal boxes and cable joints. Functions are as below. After the cable is laid, all sections must be connected to make it a continuous line, and these continuous contacts are called cable joints. A box is used at the head or end of a cable line to protect the insulation of the cable core, and connect the inner conductor of the cable to the outside electrical equipment. This box is called a terminal head. When cables leave the factory, both ends are sealed. The connection between cable and cable, as well as the connection between cable and device, need to strip the cable core, which will destroy the original sealing. A cable joint and a terminal head not only play the role of electrical connection, but also have another main function to seal the cable connection, to maintain the original insulation level, so that it can operate safely and reliably. In many cases, faults in the cable system come from the cable joints and terminals, so the design and manufacture of cable accessories is an important guarantee for the normal operation of the cable. The electric field distribution of the cable terminal is much more complicated than that of the cable body. The electric field not only has a component perpendicular to the axial direction, but also has an uneven distribution along the axial direction. After relevant calculations, it is found that the maximum electric field intensity occurs at the edge of the lead sleeve. In order to reduce the electric field strength at the edge of the metal sleeve, it is necessary to, first, increase the equivalent radius, second, increase the surface permittivity, third, reduce the volume permittivity. Therefore, according to the above theory, it is necessary to adopt measures such as increasing the winding insulation structure and the capacitor to force the uniform distribution of the axial electric field. Let's take a look at the typical structure of cable termination boxes and connectors. The typical structure of the high-voltage oil-filled cable terminal box is divided into two categories: the extra winding terminal and the capacitive terminal, according to its internal insulation. Extra winding terminal. On the surface of the insulation layer of the cable terminal, the multi-layer insulation paper is added as the extra winding insulation, which increases the equivalent radius at the terminal, and reduces the maximum field strength at the edge of the sheath. It is the biggest feature of the inner insulation of the increased winding terminal head. Stress cone. There is a transition cone surface from the edge of the sheath to the outer surface of the increased winding insulation. In the design, the axial field strength of the cone surface should be a constant, which can increase the flashover voltage of the terminal. This cone surface is called stress cone. Grounding shielding ring. In order to reduce the electric field strength at the edge of the sheath, a grounding shielding ring is used, which is a trumpet-shaped copper tube, and is closely connected with the epoxy resin sleeve. The epoxy resin sleeve is tightly sheathed on the insulating surface of the additional winding, and the grounding shielding ring and the sheath are grounded through the lead wire wrapped around the stress cone. The sleeve over the flare increases the breakdown field strength there. Capacitive terminal. The increase in winding insulation improves the maximum electric field strength, but the axial electric field distribution at the terminal is still uneven, so the length of the terminal cannot be fully utilized. Capacitive terminal is to add some capacitors at the cable terminal to force the electric field to distribute evenly in the axial direction, which can shorten the length of the cable terminal, thereby shortening the length of the entire terminal box. Capacitive terminals can be further divided into capacitive cone terminals and capacitive pi terminals. Capacitor cone terminal is to add a pole plate in the middle of the winding, on the basis of the additional winding insulation. These pole plates are often made of aluminum foil concentric with the cable axis, and the edge of the pole plate is distributed on a cone with the cable axis as the center, so it is called capacitive cone. The size of the capacitor and the length of the pole plate should satisfy the uniform distribution of the axial field strength. Capacitor pi terminal. Capacitive prefabricated pie-shaped hollow capacitors, with uniform axial distribution of the forced electric field, can be sheathed on the cable to form a capacitor pie string. Its outer insulation is a sealed porcelain sleeve. Capacitive termination not only improves the electric field distribution of the inner insulation, but also improves the electric field distribution along the length of the ceramic sleeve. High-voltage cable connectors can be divided into ordinary connectors and plug connectors. The middle connector of the cable is equivalent to the butt joint of two terminals, but it is different from the electric field distribution of the terminal. External shielding, its electric field distribution basically maintains the distribution in the original cable. However, since the electric field may be concentrated at the core connection, and the field operating conditions may be poor, additional winding insulation is required. The common type means that the connection of the wire cores should not only maintain electrical communication, but also keep the oil flow smooth, so when connecting, the central oil channel is cushioned with steel pipes, and the outer casing of the wire cores is connected by a connecting sleeve, which is connected by crimping. In the cable factory near the connection end, the insulation should be cut into a stepped or tapered surface, called a reaction force cone, then wrapped with the insulation so that the outer diameter of the cable insulation is the same, and then wrapped with additional winding insulation. Both ends of the additional wound insulation form stress cones. The shield of the cable is completely connected to the conductor wrapped on the surface of the stress cone and the additional winding insulation to form an equipotential surface. The outer shell is sealed with metal, and the box is filled with oil and connected to the pressure oil supply tank and the pressure tank. Blocking connector. The cores are electrically connected but the oil circuit is blocked. The purpose is to separate the pressure of the cable connection section, so that the internal pressure of the cable is kept at the allowable value, such as oil leaks. Due to the low voltage level of power cables of 35 kV and below, its terminals and connectors are relatively simple, but relevant measures still need to be taken at the electric field concentration, at the edge of the lead sheath. The principle is similar to that of high-voltage cable accessories. Classification. Porcelain sleeve type terminal, poured cable accessories, wrapped cable accessories, heat shrinkable cable accessories, cold shrinkable cable accessories, prefabricated cable accessories, prefabricated cable accessories, resin cast cable accessories, mold plastic cable accessories. The above is all for today. Hope our explanation can offer you some help. This channel will update more videos of power system in future. If you are interested in our videos, please follow our account to avoid missing more contents. If you don't like our videos or have any advice, please let us know. Thank you for your watching and see you next time.